Hello everyone, you're all welcome to today's class. And in today's class, we're going to continue from where we stopped in the previous class. We're going to be treating differentiation using the first principle. So using the first principle, we're going to be considering differentiation. Now, when you say differentiation using the first principle, first of all, what does it mean? So I said here, finding the derivative of a function from the consideration of the limiting value is called differentiation from first principle. I repeat, finding the derivative of a function from the consideration of the limiting value is called differentiation from first principle. So let's begin. So here is my topic, differentiation using first principle. So I have example says you find the derivative of the following from first principle. So my A, now A is f of x equals to x squared. Then B, I have y is equal to 1 over x. So my A says f of x is equal to x squared. So all I need to do is to find my f of x plus change in x. So I have my f of x plus change in x is equals to, so I'm going to substitute my x plus change in x in place of this x, which I'm going to have x plus change in x all squared. Now, so my x plus change in x, if I expand this bracket, I'm going to have x squared plus 2x change in x plus change in x squared. If I open this bracket, this is what I'm going to have. So the next thing here I'm going to have is my x plus change in x minus my f of x. So my f of x plus change in x is given as x squared plus 2x change in x plus change in x all squared. Then minus my f of x is x squared, as is being given here. F of x is x squared. So this my x squared and this my x squared. X squared minus x squared is same thing as 0. So they are going to cancel out. So I'll be left with this. I'll be left with f of x plus change in x minus f of x is equal to 2x change in x plus change in x all squared. So now I'll check what is common and I'll group it out. So if I check what is common, I'll have my f of x plus change in x minus f of x is equal to, so what is common here? I have my change in x is common. So I'll bring it outside the bracket, change in x. So if I remove change in x here, I'll have 2x plus change in x, close my bracket. So all I need to do is to divide both sides by change in x. So if I divide here by change in x, this and this will go. So I'll be having my x plus change in x minus f of x divided by change in x is equal to 2x plus change in x. So I have this. So now if I find the limit as x approaches 0. So the limit, now I'm limiting the function. Now limit as x approaches 0. I'm going to have limit of this, which is f of x plus change in x minus f of x divided by change in x. So if I'm limiting this very function as s is equal to 0, that means my change in x here becomes 0. So since my change in x here becomes 0, so I'm going to have it to be 2x. So I can come here and say, therefore, f prime of x, that's differential of x, is equal to 2x. So this is using the first principle, because if I'm limiting this function, I said my change in x here becomes 0, because as s approaches 0, change in x is equal to 0. So I'm just going to, if I substitute 0 here, I'll be left with 2x. So I'll have my f prime of x, the differential of x, my f of x is equal to 2x, as it is being given here. So the next question, I'm done with the first example. Now the next question here says I should find y is equal to 1 over x. So the first thing is I'm going to find my change in y. The first thing here, I'm going to get my change in y. So now my change in y is going to be given as 1 divided by, instead of this x, I'm going to have x plus change in x. So here I'm looking for my change in y. My y is 1 over x. Now my change in y is equal to x plus change in x. So all I need to do here is to say my change in y, or using small y is preferable. My change in y plus my y here, I'm going to have it to be equal to 1 over x plus change in x. So my change in y plus y, I'm going to have it to be 1 plus 1. Okay, I'm going to have it to be 1 divided by x plus x here. So all I need to do is making change in y subject the formula. My change in y is going to cross to the other side, and it's going to become negative. So if I like, I can remove this step, just go straight to this. So crossing my y to the other side, my y becomes negative. So I have my change in y is going to be equal to 1 over x plus change in x, then minus y. So my y from the question is 1 over x. So I have my change in y is equal to 1 divided by x plus change in x minus 1 over x. So my change in y is equal to, if I find the LCM here, the LCM here is x bracket x plus change in x. Close my bracket. Then I'm going to have x plus, x into bracket x plus change in x divided by x plus change in x. I'm going to have x here. Then I'll have minus in bracket x into bracket x plus change in x divided by x here. I'm going to have x plus change in x. So if I open the bracket, I'll have my change in y is equals to x minus x. That's using this minus to multiply the bracket. Then minus times plus is minus, minus change in x. Then all divided by x bracket x plus change in x. So from here, x minus x is going to go, because I'm going to have it as x minus x is 0. So I'll cancel it out. So my change in y will be equal to minus change in x divided by x bracket x plus change in x, which I have here. So all I need to do here is just to divide both sides by change in x. So if I'm dividing both sides by change in x, I'll have this divided by change in x, then this multiplied by 1 over change in x. So this will go with this. So if it goes here, I'll be having minus 1. So I'll have my change in y over change in x is going to give me minus 1 over x bracket x plus change in x. So all I just need to do is just to come here and finalize my solution. So finalizing my solution, I'm going to have this. I'm going to have limit as x approaches 0, or as my change in x approaches 0. Limit as my change in x approaches 0. I'm going to have it to be equal to minus 1 divided by my x bracket x plus 0. Because limit as my change in x approaches 0, I'm going to have this. I'll have minus 1 divided by x bracket x. Now my change in x is going to become 0. So since my change in x is 0, I'll have my final answer to be equal to minus 1 divided by x times x will give me x squared. So from here, I can have this as my f prime of x is equals to minus 1 over x squared. So this is my final answer for differentiating the question using first principle. So thank you very much for joining us in today's class. I hope you all learned something today. I hope you join us in the next class, where we're going to be explaining the various functions, the various techniques that are being used in differentiation. Have a nice day.